That's RFC 2131. What is it for? Well, you're going to use it to give IP addresses to machines in your network. When I say machines, it's going to be only client machines, so laptops, desktops, maybe like IP phones, stuff like that. What you will not use it for is for servers and routers and switches and firewalls and those type of things. Those will all have statically assigned IP addresses and all the information that goes along with it. The reason being is that if you were to lose a DHCP server, if it was to crash or catch on fire or someone steals it, whatever, you don't want your important servers losing their IP address information because they weren't able to renew a lease or something. Okay, so that being said, let's move along. How does this work? Okay, so your client machine, we'll say this laptop here, client, is going to send out a broadcast message, a discover message. Okay, it's going to be an Ethernet frame that's addressed to the all apps address. And what happens with that is when the switch it's connected to receives that, it's going to forward it out to every port it's got, except for the one it learned it on. And it will eventually make it to some DHCP server somewhere that's on that LAN. When the server gets it, it's going to send back an offer. That offer is saying, okay, do you want to go ahead and use this address? I have this one for you. Here's the information in it. The client machine will get it, send a request back saying, yeah, I'll use that one, thanks, or I'd like to use that one, thank you. The server will send back an ACK. That ACK will actually have all the information that it's going to use and that your client's going to configure itself with. Now, you might ask, why is this offer and request even in here? Why not just discover I need an address and ACK, okay, here it is? Well, the reason is you could have multiple servers, multiple DHCP servers on a subnet. So let's take an instance of two. Say you have two servers that are running DHCP on. Well, they're both going to get the discover message, and they're both going to send an offer message back to the client. Well, it's up to the client to pick one, and then he sends a broadcast request back saying, I'm going to use this one from this server. Now, both servers that originally sent out a offer will get that and say, okay, well, server A is going to handle it, or server B is going to handle it, and then the ACK will come back. So that's pretty much the gist of it. Again, the reason for DHCP is simply so that you can give client machines IP addresses. I should say that there is some other information along with the IP address that you receive with DHCP. It's not just an IP address. The typical stuff you'll get from a DHCP server with pretty much any DHCP server will be a default gateway, an IP address, a subnet mask, and a DNS server. Those are all handed to the client in what are called options. You can kind of draw a parallel between option numbers and port numbers. Like well-known port numbers where 22 is for SSH, port 80 is for web access, that sort of thing. It makes more sense if you actually see it happening, and that's exactly what we're going to do.
All right, guys, I got a microphone now, so hopefully this sounds a little better. Let's go ahead and actually watch DHCP happen, and by watch, I mean actually see the packets go back and forth. All right, got Wireshark pulled up here. We're going to capture on EN0, get it started up. And let's go ahead and plug in the Ethernet cable. Right now I'm on a laptop. There's no Ethernet cable plugged into it. I'm holding it in my hand, and maybe you'll hear the click as it goes in. There we go. And there you go. Oh, we're getting all kinds of stuff. That's not what I expected. Oh, yeah, actually it is. That's fine. I don't have the filter on. Let's go ahead and filter. If you're using Wireshark and you want to actually watch DHCP messages, you need to do a filter for boot P. Boot P is sort of the predecessor to DHCP. It's kind of what DHCP is built on. Okay, so you notice that I applied the filter, and now we're only seeing DHCP packets. So a little easier to look at to see what we're looking for. Okay, so here we go. There's the discover, like we talked about. There's the offer coming back to us. There's the request going out. Notice how it's a broadcast also. And there's the ACK that came back. Let's take actually a look at what came back. This is what this laptop is going to use now. your client IP address 192.168.3.21. Fantastic. All right, here's all these option numbers, right? So DHCP hands out more than just your IP address. It'll give you, at a minimum, you should get a default gateway, an IP address, a subnet mask, and probably a DNS server, at least one. You can send other things, like if you have IP phones, depending on what platform you're using, the most common thing for IP phones to need from DHCP is option 66, which is their TFTP. Boot server to get their configs pulled from, and there's these other things in here, and let's take a look at them. Your domain name, option 15. This is lab.com, okay? That's my lab environment. Router, what is router? Well, that's actually going to be your default gateway, and there it is. That makes sense. Subnet mask is option 1. Let's take a look at this. I'm going to show you something interesting. Okay, so here's your release time, 1 day. Okay, so I got my DHCP server set for 86,400 seconds. Every day, the DHCP server is going to get rid of this address if it hasn't had a renewal. But if you look here, the renewal time is half that. So every 12 hours, this laptop is going to try to renew this IP address. It's going to try to renew the lease. Say, I'm going to go ahead and continue using that. I'm going to go ahead and continue using that. And this process will occur again, and the server will say, okay, it's yours. If it doesn't hear from my laptop in 1 day, the server will go ahead and recycle that IP address and potentially give it away to somebody else asking for an IP address. You can get a lot of information on these option numbers. There's a whole bunch of them, for all kinds of things. But there you go. There it is. There's your discover, your offer, your request, and your act, just like we had discussed.
Show you how to see your IP information on a Windows box. This is just a Windows XP machine. This is going to be the same for XP or for Windows 7 or Vista or Server 2003, whatever. It's going to be the same deal. You know, come out, command prompt, get this out of the way. I don't know if that actually shows up in the video or not. And you can do IP config and hit enter and get some information, or you can do ipconfig space/all and get the extended information. You actually see that on this particular machine. It's an important machine to me. I don't want it doing DHCP, so it's actually disabled. You can see that right here. DHCP enabled? No. But you can still get the address and subnet mask gateway and its DNS servers and so forth. That's all command line stuff. You can actually go and pull up your network properties. There's probably 100 ways to do this. You can go in your control panel. Go to your network connections. And you can see them connected here. So we can open that up. Take a look at the properties. Go to the TCP IP properties. And here's where I've statically configured the address on this particular machine. It's a virtual machine. If I wanted to use DHCP, I would have checked that bubble right there. Obtain IP address automatically. And then once you click this, this will also highlight and allow you to say to obtain your DNS servers automatically as well. So that is how you do that. Next thing I was going to show you is how to actually configure a DHCP server on a Cisco router. So let's go ahead and do that right now. What can we get to? Let's take a look at Alright, this one already has it configured, so that's great. We take a look. So you would type IP DHCP pool and you name the pool. You configure the network that you're going to hand leases out on, and this one's 192.168.3.0 with subnet mask, 24-bit. You let them know what the default router is going to be, the domain name is going to be, and let them know what their DNS server is going to be. And that's really enough to get it going. What you really want to do, though, oh, here it is too, is exclude some addresses. I usually exclude them at the beginning of the range. I think most people do, but you can exclude them at different, ends if you want. You can exclude them in the middle, at the end, whatever. But what this is going to do is right here, IP DHCP excluded address 192.168.3.1 through 192.168.3.20. you'll see that that's within this range. Well, what happens is that when a client asks for an address, it's not going to hand out anything within this range. It will start after this range. So it'll hand out 21, 22, 23, 24, and so forth. But it will never hand out anything within this range. And that's good because that way you can use those addresses on your subnet for other things, router IP addresses. Maybe you got some kind of server or something on that particular network that you don't want to use a DHCP lease for. HSRP addresses can chew up a couple. If you're going to do like GLBP or something, that would even chew up potentially more addresses. So I think it's probably pretty good to have about 20 addresses of a range excluded to use for other things in the future or stuff you're doing now. I will attach to the video at the website SeanDaniels.com. At the bottom there'll be some links where you can actually pull this config, download it if you want to. I'll put that little graphic I had on there as well. And if you want to see something else, email me and I'll do it. If you think I'm an idiot and you want to email me and tell me that, that's fine too. Let me know. Like I said, this is the first video I've done, and hopefully they will get better from here. Thanks for watching.